Let me remind you how cases works. Let me make a list of random integers. Let me say my list is random integer, and let's say maximum of 20 and give me 8 random integers. And then let's pick out all the odd numbers in this list using cases. So cases of my list of all x such that x is odd. That's a typical example of how cases works. And for this particular type of example, there's actually a function that works more easily called select. So I'm going to select from my list, well, again, all the numbers which are odd. And I can write it like this. And let me show you the documentation for select. So select takes two inputs, a list and a function, and then it's going to select all of those elements in my list or in the first input such that the function returns true. And it's going to put those elements into a list like this. So from this example, select, I would say, is definitely better. Why do we sometimes prefer cases? And why have I taught you cases so far, but I haven't taught you select? Let me show you some other examples. So instead of saying, just give me a list of 8 random integers up to 20, let me say, give me 8 length 4 lists. Okay, here are 8 length 4 lists. And this is a good chance to point out that random integer in Mathematica works a little differently from rand_i in MATLAB. So in MATLAB, the minimum is always assumed to be 1, whereas in Mathematica, here it's assumed to be 0. And if I want to force it to be 1, I can do that by just explicitly putting this first term into a list. And so now it says, start at 1, end at 20, make a random set of 8 lists, all of length 4. Okay, and I could put another number in here too. So this is, give me 8 lists. Okay, we'll see if I can find the first. There's the first of the 8 lists, and within that list, there should be 4 lists. And within that set of 4 lists, each of those should be a list of length 2. Okay, so you can make this go on as deep as you want. Okay, it just gets more and more complicated. But let's go back to 8, 4. So I have 8 length 4 lists. And let's find how many, let's stick to cases. Let's find which of these lists, let's say, start with the number 12. So I want all x inside of my list such that x double brackets 1 equals 12. Okay, so there's this one, and there's this one. And how would I do that using select? Well, here I don't think it's going to look as natural as this previous one where there was a nice built-in function that did exactly what I wanted. So I want some function here where it takes as input a list, and then as output returns true if the first element in that list is the number 12. So one way I could do that would be, I'm going to use a pure function here. I want to get out the first element from the list. And then I want to know, does that first element equal 12? And then what do I do to finish a pure function? I always finish it with the ampersand. So for example, pound you're supposed to think of as the input variable. And if I input this list here, then the output is going to be false because the first entry is not 12. Whereas if I input this inside list, then the output will be true, and so it will be kept in this select. Okay, so we get the same answer as up here. And here's another way to write it with cases. I could say, so I'm supposed to give a pattern here, and I could give the pattern 12, anything, anything, anything. Okay, that does the same thing. And I don't know an analog of that for select. Here's one other way that's especially going to be useful for us once we start talking about string patterns. And that is to say 12, and then 2 underscores. And what do these 2 underscores represent? That means any like 1 or more element afterwards. So I don't have to write out the 3 underscores explicitly. And here I get the same answer. As another example, what if I want to find all of the inside lists of my list that contain the number 11? So how could I do that? I could do cases of my list, all x such that count of x, and I've forgotten something. I forgot to say what I'm counting. Count of x, count of 11 in x greater than or equal to 1. So here are all the inside lists. Let me delete some of these previous results so it's easier to look at. Here are all the inside lists inside of my list where the inside list contains the number 11 at least once. So how can I do that using select? Well, I can say count pound greater than or equal to 1. And here again, I forgot to put in the 11. So all of those inputs from my list, where if I count 11 inside that input, I get at least 1. And I got the same answer here. There's maybe a simpler function if all I care about is does it occur at least once, and that's that I could use member q. So member q doesn't care how often 11 occurs, it just cares that 11 occurs. And for the select version of that, I can say, so again, needs to be a function. Again, I'm going to use a pure function. And so there, my function takes as input any of these 8 inside lists, and as output returns true if 11 is in that inside list, and returns false if not. So the main things I wanted to introduce in this video were how to use select together with pure functions, and also this notation with multiple underscores. And maybe I'll do one more with multiple underscores. So let's do cases of, let me just put in an explicit list here to show an example. Say 7, 13, 7, and 10, 7. Okay, I want all the cases in there that are of the form 7 followed by, and let me make these a little deeper. So let's say 10 and 9. So I want to, here is my list, and then I want all of the things in that list which are of the form 7 underscore underscore. And so notice how this one did not show up. I would say it should be clear that this one's not going to show up, because here 7 is showing up as the first entry in the list, and here it's not the first entry. But why did this one not show up? Well, that's because underscore underscore, that stands for 1 or more something. If you want to do 0 or more somethings, then there's another way to do that inside of Mathematica. You put in a third underscore. And so that says it has to be a pattern of the form 7 followed by 0 or more other terms. So here it's a 7 followed by 2 terms. Here it's a 7 followed by 0 terms. And just to remind you, what if I put in a single underscore? Here, none of these 3 entries match this pattern because none of them are of the form 7 followed by exactly 1 other element.